Myself, I'm Ashok. I'm working as a technical account manager in DigitalOcean. So I'm also a Cube astronaut and I'm also Istio certified associate certified person. And along me, I have my co-speaker, Isha.
Myself Ishwar Rajan. I'm technical lead at Accuknox. I usually like to introduce myself as a developer. So we'll start there.
Yeah.
So the topic is actually production ready gRPC. How to achieve or how to come up to a point where we make our services that we deploy is production ready. So since we are attending many sessions from the morning and we have gone through this usual stuff, when explaining gRPC, it's like high performance microservices, it's protocol based. The main thing I like to say is I've been using it I'm into the Kubernetes field for the last 4 to 5 years, and the best part I've been using about gRPC is that the protocol buffers thing, protocol thing. So when I talk about gRPC is language agnostic. Your client and server can run in any language, it does not matter what it is. You have a proto buffer or proto file defined, and the server and client knows that they can use it to communicate with each other. And the next thing is strongly typed, Rust language, speed and simple. So consider you have an application developed and you have it being deployed and you're testing it. It developed using gRPC as a base, and you might be having multiple microservices connecting with each other. Those you might be running in testing or you'll be staging it, validating it. So how to developing is fine, you develop it, you have it available for production, but how to make sure you have it available or ready for production. So there are certain factors from my opinion or from my experience say this all needs to be met to make sure like you have it production ready. So the first thing I would like to say is, yes, I like to bring this point. So when we say production ready, I'll say like there are certain best practices or certain things to be considered into having in mind to achieve production ready. So first thing I'll say is developers should be focused on mainly writing the code or the business logic of the gRPC, like the application, whatever you're focusing on, not extra codes or thing to write like the other stuff like where we are achieving getting the metrics and retries and so on. So our code or the application or the service should be capable enough to make it production ready. You should make sure it should be like supporting like retries, proper retries, and canary deployment. It should support monitoring as it is out of the box. And the pain point there is each RPC calls, each inbound and outbound records that goes through and comes into the service should be secured through an mTLS server. So all this should not be done mostly by other than the business logic. Like maintaining all this shouldn't be a headache or like should be put mostly by the developers. It should be supported out of the box. There are many solutions or there are many ways to achieve those. So I'm handing it to Ashok so that he will explain you how we can achieve like routing, canary deployments, and metrics out of the box, like having an application in place, changing or nothing modified in the code, and achieving all those steps, all the points, how to make it easy and feasible. Over to you, Ashok.
So that's where we are adding gRPC along with service mesh. So we call it as a gRPC supercharger. So we can have various service mesh that are out there in the market. So for our talk, we have chosen Istio, the famous service mesh. You can also make use of Cilium as well. They both are most widely used. Cilium is a CNI which can include the service mesh features as well. Istio is major service mesh. So what service mesh is? Actually, it's a dedicated layer to handle all your infrastructure related networking, the data plane as well as the control plane. Both the things as given in the service mesh. Service mesh has sidecar proxies, and we also Istio also support ambient mode where you don't need to install a sidecar. It can be a single sidecar as well, single standalone container as well. Sorry. So this is the architecture with Istio. So it was actually taken from the Istio official documentation. So this is where you have the ingress traffic and then we have the proxy injected in a sidecar mode. This is actually a sidecar mode, and then we can have proxy to proxy and then to the service. It actually adds a single extra hop. That is one drawback here. But when you consider when you have a bigger clusters which have a lot of services and all the microservices talking to all things, and instead of going for mTLS, using open telemetry instrumentation for your application related observability and all those stuff, we can make use of service mesh like Istio there. That's the major thing here. So yeah, that's what we have used service mesh for. We have taken care of security using mTLS. Istio provides a authorization policy where you can set it to various mode. It could be restricted, or it could be strict, or it could be permissive. So if it is strict, what happens is the two services which connects should have a mTLS between them. So that mTLS will be taken care of the sidecar proxy, which both will have a mTLS certificate, rotation, everything. Those sidecar proxies take care, so you don't need to worry about making it secure. So that sidecar proxies will make the connection secure, so it will be a secure mTLS connection. And then Istio also has various ways of configuring your load balancing algorithm as well. Usually any cloud providers might go with a round robin algorithm, but Istio has this feature to change that round robin to least request, least can request. All those options are available with Istio. And same ways goes for if you have any conditions for doing a retry, or if there is any error, you need to restart the service or bring down the service. All these things you can do with fault abort injection with Istio. So this is what the security policy, as I mentioned. So there are various modes here. So once you do strict, so the service in the namespace where you have deployed, for example, here it's a full namespace. So in this namespace is a Istio enable namespace which has the sidecar proxy. So if it has to connect to any other service, that the service namespace should also have Istio injection enabled. So then only the mutual communication can happen through mTLS. Otherwise, the communication will break. There is no, because since you have established a strict mode here, whatever services in this namespace can never connect to any other service without mTLS. So that's the strict one here. And same way, we can do the routing for the load balancing and all those stuff, retries, fault injection, and then as Ishwar mentioned, the major part is, so you have application running in your production and you want to test your application change in the production environment without affecting the major production environment. So what you can do is you can make use of the canary deployment which Istio provides, canary options, so that you can either use a mirroring option. Istio provides a mirroring option wherein you can mirror whatever is the exact code that goes to your production main service. You can mirror that to a new service where you have made the major change or any new change to the code that can get the same traffic, or you can do canary mode, like 75% to the or 90% to the new old service, 10% of traffic, production traffic, you can send it to the latest version and see how it works in the production environment as well. So that is very helpful on that. And then for the observability as well, we can make use of the sidecar proxy related metrics and all those things, and pass it on to Prometheus, Grafana, Jaeger and all those things to get the tracing and all those things. So it can, if it's a in-service, in-cluster communication, you can make use of the sidecar proxies that are there. But if you want to even observe whatever is coming from external traffic, that way you can make use of the previous topic, the gateway. So Istio has the ingress gateway by default that can capture all the incoming traffic, and you can also make the external like the response from your cluster to external world can pass through Istio egress gateway as well. So in that way you are capturing the external internal request as well as the response which goes outside through Istio egress gateway, and you can put a observability based on that. So that's the major part here. We'll quickly jump on to the demo here. I'll hand it over to Ashok for that.
Yeah, so I'll just explain what is that scenario, or what is that use case that we are running here. So this is the code. I'll just skim through it faster. So we just have a server and the gRPC client running. So the server we have divided, like we have created two versions, V1 and V2. we have a single client running. So if you see the server code is not much big. It's just like a gRPC service serving on a specific port, and it's not like secure. It's not like it's an insecure connection currently we have to show that mTLS security is happening at the Istio level. In addition to it, what we do is like both the services, like the payment V1 and the V2 service has the same code running. It doesn't have anything hard coded. The response we get from the client, we will be sending out the request we get from the client, we send a response out saying this is processed by which service, either V1 or V2, whatever it is. And we have like it deployed. I'll show you both. We have certain policies to define the weightage and the load should go to which service and how the weightage can be maintained. I'll show with the initial one what is running. They'll also able to show a modified weightage saying it goes only to one specific service and blocks the complete other one. I'll show you that. Hope the screen is visible and I'm not.
Yeah, it's visible.
It's okay, right? Fine. As I
We
said,
have a DigitalOcean Kubernetes cluster making use of it. We have installed our application in the payments namespace, and we have also installed Istio as well. Can you just show the Istio?
Yeah.
Istio system. Istio is installed in this namespace called Istio system. So we have the Istio egress gateway, the Istio-D, and then we have also enabled the Prometheus as well as Loki, Grafana, the observability part as well. We have also enabled it in the Istio system namespace as well. Istio itself has this capability, so we have leveraged that as well. We can also have a separate implementation of Prometheus, Grafana inside a cluster. Go ahead.
yeah, so I'll just go inside and log both the services just to show where it is like. So what is happening is client is sending out requests to both, like the service, not any of the pods, the service every 10 seconds. So whatever service it is, either the payment V1 or the V2, that label is sent as a response for tracking. So you could see multiple times you are getting a response from payments V2 service and then V1 service. So how do we define it actually? If you can see this, yes. So there's a policy which says virtual service. In this virtual service, we have defined the weightage as 50-50 for both the both the services.
So before that, I can add. Can you go to the destination rule? So before adding a virtual service, you need to add a destination rule wherein you have given to select the labels for subset. You have to give a subset wherein you will give this V1 is actually in the old subset, the old deployment, and V2 is the new deployment which we have, and we are given the subsets here. So we have to use this subset in the virtual service file where you are giving the weightage. So if you give based on the V1 subset, it will go to the older one based on the destination rule. Same thing if you give for V2, it will go for the new service which you have. Currently we have given an equal weightage. Now let us change, we can also change this weightage. This is actually where, it's like a canary one. What we are doing is actually a canary one where we are switching the traffic, like with this weightage itself. Now we want to go, what he has made is, he has made all the weights, all the response to go to the V2, new request. Now the older service will not get any
request. Yeah, it will just apply it.
Yeah. We have to just reapply the virtual service once you make the change. Yeah, we reconfiguring the virtual service.
So okay, it's configured. So now I'll go back to the screen where I can show you this one here is V1 and this one here is V2. So if you see, you won't be receiving any traffic in V1 mostly. All the traffic are routed to V2. That too without a restart in the deployment, no change in pod and the configuration stuff. So all the requests for the client, right, responses will completely V2. So the similar way the weightage can be defined. So consider if I make changes or made an additional whatever is it, a new deployment, the deployment can give a specific weightage. This way the canary deployment can be achieved. In addition to it, Ashok, if you want to explain it more.
Yeah. Can you go to the peer authentication? So this is where we have made we have made the namespace as payments, and we have made the mTLS mode as strict. So now what happens is, if any other service or any other communication, in-cluster communication, it has to happen to this particular service in this namespace, payment names, any service. It has to have a Istio injection enabled. Otherwise, if you try to deploy a client and try to access this, you will get an error. It needs a mTLS to connect to the service. That's what. Default namespace is not Istio enabled currently, so you will not able to connect. Even though the gRPC server which we have in the code is insecure, but we have secured with Istio now. None of the other service without a mTLS can connect to that payment service. This is the use of that peer authentication policy. And it also has various authorization policies as well, which you can further add. Even though I have made strict for the entire namespace, you can ask me a question. There can be any other service in that same namespace that can connect to the my payment service. So that how to restrict that is Istio not only has this authorization, it also has the authorization policy. Like you can provide various fine-grained permissions, like who can do /get in that particular service, or who can do connect even to the service, send request to that service with the help of the principal section which it has for the like a service account or service account related or any other deployment label. You can select the match label only from this particular service. This payment should get an incoming request and all those things. Even though in the mTLS mode you can further secure. That's the next other feature you get with Istio and all that stuff.
So in addition to this, if you have seen the code already, I have like pointed out that in the code I'm not using any extra thing to enable or push metrics. So since we enabled Istio, I'll show like by default how metrics is visible. Here, yes.
Yeah.
So
we have just port forwarded a Grafana service which we have, and here you get all the request rate and what is the duration, all those stuff for the various services. So we have selected the particular service, and you can see all the request response, duration, all the stuff. And we also have a Prometheus instance where you can check for how many requests got failed or whatever is received, and all those metrics you can scrape as well. And further you can do all this observability part for your application.
So here, yeah.
Yeah. So how much is went for P1, V2, and all this stuff you can query with the Prometheus.
So it's like how many like outgoing requests, how many incoming for which service payments, V2 payments, V1, what is the incoming. So all this will be recorded here.
Yeah. And we also have, can you go for the examples? We have the example policies as well in this repo. After this talk we'll share this repo as well. To those who want to try it out, they can try this out. And we have also added, as we said, the fault injection policy, the retry policy as well. So we have added various retry attempts, how many, and what should be the timeout for between each retry, and you can see what retry on what all specific errors you need to retry, and then what is this is the route of the thing and all those stuff, and can go for the fault injection as well. So we have also made about status as well. So if we get a 503 and the value is 30% of the traffic gets 503, we can abort that particular service, and you can configure your own logic as well. It could be 503 or 501 or service not available. Whatever is the error, what you want to abort it, you can do it without changing anything in the application, gRPC code or something. That's just the major use of Istio and all that thing. Yeah, that's it for our demo. Yeah, we have some time. Is there any questions?
For mTLS case, like do we have an error on the client side? Like what do clients see? The error you were showing was on the service side, right?
No, it was on the client side. It was on the client side. We showed the client port logs.
Okay, that
showed the connection reset bit here.
Okay, I'll explain you this way.
This is actually the client. We are showing the logs of the client port.
Oh yeah.
It's a client. It's a client we deployed in a default namespace, not in the payment namespace.
So what happens is if you see kubectl describe NS payments.
So this is the label which has the Istio injection enabled. To have the sidecar proxy injected, you need to have this annotation in the namespace. So default namespace currently doesn't have that namespace. So number of pods will have the sidecar proxy injection by default, by automatic. They'll have a single container of your application. It never has a sidecar. And you can do the same thing with Cilium as well. If you're against the sidecar proxy, Cilium can do this with a single envoy proxy it has. With Cilium you'll get one more advantage is that Cilium for L3 and L4 Cilium makes use of eBPF. but Istio doesn't make use of eBPF. Silly makes use of eBPF for L3 and L4. For L7, like Istio, it makes use of Envoy as the proxy. That's that.
Have you tried like proxyless service mesh? Like what disadvantage did you see in that?
So we haven't actually tried. Today morning only we came to know about proxyless.
That's what we were
So
discussing.
basically,
The XDS client, which
so
was
basically
explained.
all these things like so basically you are configuring on the Istio side, right?
Yes,
Yes.
nothing in
And
the
Istio is sending you configuration which is XDS protocol.
No,
Like
Istio is injecting a sidecar running in the pod
Envoy.
itself.
Okay.
It index Envoy.
Yeah, it's like sending a configuration to Envoy.
Envoy.
So basically gRPC can listen.
And listen to the Envoy. That's what we are doing. We are
Since
not doing
gRPC is written on top of HTTP 2, right? Istio supports that.
HTTP 2.
That's how it
It
works.
supports HTTP 2 traffic from there.
Hmm.
It does
And
there.
do like try it out and like share with us like
Sure.
changes we do see.
Yes. So thank you.
Thank you.